like I said, this is like the quiz, test, study, practice, study. Look at this. My anticipation for you, set of notes front and back over and over and over and over again, because if you can do this question on the front and the question on the back, you can do the questions on the quiz, you can do the questions on the test. But if you can't do the front and back of this, you need to practice as much as possible until you can get there. Make it as similar but not exact to the test and the quiz so that you are successful, because application problems can be very difficult. So our examples are always about Ferris wheels, because Ferris wheels most like the unit circle and they go around in rotation, so that's where we get it from. So it's telling me height in feet at any time t in seconds can be modeled by this equation. So important info is the function, the fact that they're giving me the labels, and so on and so forth. And then it tells me the Ferris wheel turns for 135 seconds before it stops to let the passengers off. So first thing that we need to do is state some important information. Now, on the quiz or test, they will not give you A or B. They're going to give you C, D, E, and F. I gave you A, what you should do for your first step each time. So your first step would be to state the amplitude. So amplitude, what is the amplitude for this one?
25.
Perfect, 25. Okay, that one was easy. Now we have to figure out the period. So period. What is the formula for period? 2 pi over b. So 2 pi over b. And what's my b value? I just b again, sorry. Yes, pi over 15, thank you. Now for those of you who struggle with complex fractions, that means that we have 2 pi times 15 over pi, which means the pi's cancel left with 2 times 15. What's 2 times 15? 30. So the period is 30 seconds. And then we have the phase shift. Does anyone remember the formula for phase shift?
C over B.
So we have C over B. C is 5 pi, good. Remember, it's the opposite sign, so it says negative, positive 5 pi. Over B, and B is, you told me before, pi over 15. We have another complex fraction here, so I have 5 pi times 15 over pi, and 5 times 15 is 75, good. Then we have the vertical shift. What's the vertical shift? The D value. So what's my D value for this one? 30, perfect. Okay, now before we even get to graphing anything, we're going to have to figure out what we think the window should be. So the X, and really I should say something about over the course of, because to graph your height in feet over the course of one rotation of the Ferris wheel. Rotation, not the entire thing. Yes, Logan? What? So my period is 30 seconds, but I have a phase, so we might want to be careful with that. I mean, I don't mind if you graph it from 0 to 140 and look at it, but when we actually go to graph it on here, we only want to do one rotation. So if you want to graph, you could do 0 to 140 if you want to in the calculator. On the sheet, you want to do that because you're only trying to graph one rotation. So if you want to do that for just your purposes to see, that's fine. Y minimum. 140 is, it tells me that it takes 135 seconds. What about the Y minimum? I mean, that's, you don't hit the ground. You can start at 0 so you can see it, because that is the ground, but I mean, it shouldn't be that complicated. You're just looking at, okay, what's the minimum this thing goes and what's the maximum? What's the highest our Ferris wheel goes? Nope, doesn't go 30 feet. That's my midline. That's average. What'd you say? Nope. 25 plus 30. 55. So we might want to do about 60 so we can see the top of it. But you have A plus D, because that's going to tell you your maximum. Because remember, your amplitude is the distance from the max to the midline. So if you take the midline and the value, that'll tell you your maximum. And then we could go by 5s, I guess. So just for our purposes right now, I want you to graph the function, and then we can go back and graph it for only one rotation. But at least this way you're able to see what the whole thing would look like over that amount of time. So we don't need a y2 for this one right now. We haven't decided we needed that. So we're just typing in 25, 9. I would use parentheses around the fraction itself. If you want to look at my calculator, that's what it looks like. And go back in and change your window. And when you go to graph it, that's more than just one rotation of the Ferris wheel. Like you're seeing it goes around and comes down again, goes around, comes down. So this would be the entire time that you're up on that Ferris wheel for a whole ride. They don't just take you around once and then get off. That would be really lame. So they take you around a couple of times and then you come back down, and that's the whole trip. So this is the entire ride. We just want to graph one cycle. So this is good for us to answer the questions at the bottom, but let's graph one rotation on the graph. So I'm going to take my ruler. Now, just an FYI, on the quiz and on the test, this is a 6. You screw up the graph, that's minus 3 points right there. So don't screw up the graph. And what I'm trying to show you, as long as you do something that looks similar to this, you'll be fine. We'll put your labels on here, so we have to make sure we go through and put the labels on. What's the y-axis going to be? Y? Height, yeah, how tall I am. So this is height. And how is height measured? Okay. Then the x-axis is measured by time. And how is that? Okay. Now, for this particular graph, I'm not sure what you want to go. We know we have a phase shift of 75. So, and the period is 30. So 75 plus 30, that's all the way to 105. So as long as we get from 75 to, let's make the maximum, let's just go by tens on here. I did like the full 140 so that we had it. I'm fine on the y-axis as long as you put the 3 main points. So the maximum, which is, what's the maximum of this graph? Well, it's not actually 60. That's what our window was. Our actual maximum is 55. And then we have, let me give you a hint. It's the d value minus the a value. 5. So 30 minus 25 is 5. And then halfway, I would say, that's my midline. And what's the midline? 30. And I'm actually going to draw that in a different color. You can choose the same color. It doesn't really matter. So that's y equals 30, my midline. Now, if you still want to create that little XY graph, like we did on the other ones, you can go ahead and do that, if that helped you. So if you want to create X, Y, so you know where to put the points, that's fine. If you can do it without, that's fine. So since we are at a sign, we're using a sign function. That was what the original function was. Where are we starting? Min, max, mid. What'd you say? Mid. And then from the mid, I go where? Max, mid, min, mid. It's not negative, so it's just a normal sine curve. The midline we know is at 30, so all of our mids are at 30. The max we know is 55, and the min we know is 5, so we know all the y values. Now my x, I figured out my phase shift up top. It's my starting point. And one thing that we didn't talk about is the increment, but I know my 75 plus 30 is 105. That's where I'm going to end up at the end. Up with your increment, or you can just take it, well, really that's what we're doing. So take the period, which is 30, divide by 4, because that's my increment, that's 7.5. So I'm going to take 75, add 7.5, that's 82.5. 5, add 7.5 to it, it's going to give us 9. 90 plus 7.5 is 97.5, and then you added 7.5 again, you'd get to your 105. So just like all the other ones, you don't have fractions, you have normal numbers, which is actually a bright side. So if I'm just doing one rotation, I'm going to do this little piece here. I don't have to graph, so I don't have to graph all of that. I just have to graph one rotation of it. So at 75, which is about halfway here, I'm at the midline. At 82.5, I'm at the maximum. At 90, I'm at 97.5, I'm at the minimum. And at 105, I'm at the midline again.
Wait, how to get 82.5 and you said you added, what was the other?
7.5, because the period divided by 4 is the increment. You need to write down underneath here, increment equals period divided by 4, which is that 7.5. That's how I went from here on and on. So this would be a really awesome 3 points. It has the labels, it has all of my intervals, and they're even. I went evenly from 0 to 140. I have my midline on there. I have my graph on there for one rotation. I didn't do the whole thing. I just did one graph that you would get your full credit on. And that's half of the entire thing. I have to answer the questions at the bottom, and then we're done with this particular problem. Now, this is where, like letter D, I would want to have the actual calculator in front of me where my value of 135 is, which we kind of could figure that out pretty. So if you want to just use your calculator, type in second for a value, so number 1 of 135. And it tells me I'm at what? I'm at 30. So I have, and you didn't have to do that. You could, it kind of depends on what you prefer. You could just plug that in for x and solve, but that's up to you. So we have the height at 135 seconds is 30 feet, which is my midline. So when are you at your maximum height for the first time? Well, we need to figure out what the where the point is. I'm actually going to trace this over. Okay, so I know my maximum's somewhere in there. I traced it all the way over because my 135 was over here. I needed to go back over here. And I'm going to do second calc, and I'm doing my maximum, so that's number 4. And we've done that in the past for quadratics. And just go a little bit to the left of that very first hump, okay? Then a little bit to the right of that first one, and then just hit enter instead of guessing, and it'll tell you your time at my maximum height. So at y equals 55, you have a maximum of 22.5. So this is what I did. I hit second calc. That was number 4, which was maximum. And that's left and right of first cycle. And then to answer the actual question, I am at a maximum height at about 20, which is the first time. Like I said, these problems you need to keep practicing over and over. So even though I have this, I can print more out if you want to practice it all over again, because I guarantee you this will look like your quiz. You have one last question, and so what is the domain of this function? Justify your answer using mathematics. So what do you think? 0 to what? 140? I would say 0 to 135. That was 140, but it took me an entire 135 to do that. But no, you had the right idea. So the domain is 0 to 135 because it takes 135 seconds for one full trip around the Ferris wheel. Doesn't mean I just go up and down once. That means usually the trip is go around for the full trip. So this is the first side that you're going to have to be able to do on the quiz or the test.